Today's session is going to be about DevOps in the world of OpenEdge. We have started about a year ago researching how we can improve the experience of developer. And that journey led us through collaboration with you, partners, customers, to the concept that is currently run as an incubation, so-called Project Hub. So I'll tell you all about that, and in the end I have some conceptual wireframes to share. All of this presentation is intended not only to share with you our thinking, our latest kind of progression, but also to invite you to collaborate with us. We have established a customer validation program that is open to everyone to join, and there we share all our progress, day-to-day activities, ask questions, hear your input, and collectively build a better solution. Before I go too much further, a lot of you are familiar faces. I know you, but those who don't know, I'm Oleg Cooperschmidt. I've been with Progress 1.5 years. I'm a director of product management for OpenEdge. So, since I'm talking about, I've done this before. Now you're supposed to clap. All right? Okay. Okay. Try again. Because there is some, this is not a finished product. We are exploring. Everything I'm telling you is our intent. It can change, so standard disclaimer. Now, let's get to the meat of it. What we are going to talk about, a little bit about DevOps, but largely everyone knows what it is. There may be different interpretations. I will try to explain why we are interested to help you do that and what challenges we are trying to address. And then I will share with you where we are in the journey so far. So if you're interested, you can try. There are many definitions, which I just was presenting in another session with John Weiner from Vermont Systems. The intent is to reduce time that it takes for your team to produce working software and deliver it with confidence to your customers. Whether you host or not, that's a separate story. But it's more of an operational aspiration to improve the flow, okay? There are a lot of complexities in modern development, different stages, different activities, cross-functional teams. How do we address these challenges? Just a snapshot of what might be involved in the world of OpenEdge. And this is not a complete by any means picture. At the bottom left, you have a repository where you can store your code, your configuration, scripts, why you want to store it in the repository, so you can version it, you can recreate this with confidence, you can ensure repeatability. At the top, you see binary artifactory, whether you use third-party products or your var files, your runtime code, you want to reliably store it somewhere and take it out to deploy in production. If you use containers, you will want to use something like Docker registry, so again, you can automate how you store and retrieve your runtime container images. Along the way, there are different tasks and activities performed by different members of your team, whether they code, build, test, secure, deploy, protect, on and on and on. There are different activities along the way that involve different team members, different specialities, require collaboration, dependencies, risk, managing risk. So we've all seen that, but the pipeline kind of pushes it to the next extreme because in the modern world we are competing at how fast we can introduce changes to our software. Customers are increasingly expecting this to happen overnight, or even nobody wants to talk about versions anymore. If you really think about your mobile phones, you don't know when your apps are updated overnight as we speak, and new features just show. I know it's nirvana, sounds like we will never get there, but guess what? We want to help you get there. So, what's involved in DevOps? Well, procedures, tools, people are the main elements of DevOps, and I would organize kind of the benefits, a lot of things that influence DevOps in the past years and forced people to reconsider and take it as a discipline. And cloud and containers are some of the components that unlock new efficiencies for us and new value. I break down the 4 benefits into developer convenience and business necessity. The first one is ease of deployment. Whether you are developing or going to production, modern cloud and container technologies help you to do it faster. If you think about it, faster means your productivity can benefit, right? So if you think of a developer who in a traditional world operates on a local machine with its own database, own application server and development studio, what happens when this developer wants to deploy a fresh database? Well, it takes time to configure. You have VMs, you need to wait for IT, open tickets. All this slows down your productivity. Okay, so with containers, you can spin it up in seconds and have a fresh container ready, pulled from registry. Improved resource utilization. At scale, it matters. It translates to cost savings. With modern cloud and container technologies, you can pack more applications using fewer computing resources, and you can make it elastic, so it shrinks when you don't need those computing resources, meaning you save money basically on that. High availability. Those computing platforms enable you to all of a sudden benefit from solutions for high availability that previously were not available and required you to either build your own. 10, 15, 20 years ago, high-end enterprise software, if it wanted to be highly available, needed to have its own proprietary high-availability solution with primary, secondary, failover, or use a third party, which costs money and requires administration and complex configuration. With containers, you can drop them in clusters. If you master orchestration technology like Kubernetes, you can be very intelligent in how you manage these clusters and stay always on at scale, whether your load expands or shrinks. And finally, faster time to market. This is directly related to competitiveness. You have new ways to introduce changes to your product, whether it's fixing bugs or improving or adding new capabilities. There are this concept of feature tagging. How many of you heard of feature tagging? So just for those of you who haven't heard about this concept, Google Maps, for example, when they introduce changes to maps, they roll them out first in a small region called Australia. All right. Australia is a very technologically savvy country, but they're able to actually control how they release capabilities, and they know when they build features where they are in production pipeline. Are they mature? Are they in testing and preview and staging? So what if you had capabilities, if you are hosting or planning to host product, to have a refined, fine-grained control instead of a version of the software, instead have ability to control which features are available when and to which customers. This is where the world is leading. And granted, we are not quite there today, but we have to start work now so that in 2, 3, 5 years, you have this. So all of this activity is continuous by nature. It's not start and stop. In the old days, with a waterfall type of mentality, we would think a lot, plan, and then go for a year and build, release, and announce. Here, we're increasingly approaching the world where we want to continuously iterate and improve products, and this will make us more competitive. And if we don't want to do it, our customers want us to do. So hence, we are looking for ways to do that. Each of these phases, whether we are talking about coding, building, testing, is supported in our world by different types of tools, and oftentimes multiple tools that are highly specialized. For example, coding is supported by compiler, so there are different compilation tools. Building, you have different tools, so test frameworks, ABL unit, JUnit. We have code coverage tools that our partner Riverside Software supplies, helps with OpenEdge. Deploy, operate, so monitoring, we use OEM to monitor. That's kind of a standalone thing. How can we integrate it all so it flows nicely into one pipeline? To break it down further, here I give some more categories. Coding, build packages is all part of continuous integration. Continuous testing itself involves a range of different tools, whether it's performance, whether you're scanning for security. And so, by the way, in each case, you may not necessarily require all of these categories, but the point being that at some point the proliferation of different tools your teams are dealing with will start to show its complexity and challenge your efficiencies. Now at this point, everybody should turn your head to the left. Here is an attempt. I couldn't resist the pleasure of sharing this with you when I came across this diagram. By the way, this is on Git, so you can find it. You will get this presentation. Somebody attempted to map out DevOps world, the complex world of DevOps. If you think of DevOps, of course, the world itself is comprised of development and operations. But the reality is that DevOps engineers oftentimes have to be multi-talented, multifaceted, and know different domains that go way beyond what developer knows. It involves database administration. It involves networking, setting up firewalls, security certificates, integration with single sign-on, SAML, and then all kind of configuration tools. And so the world is complex. The tools, plenty. Here's a periodic table of DevOps tools, courtesy of Xebia Labs. Each color here represents a different category. I'll just read a few for you. Testing, for example, this is all different. By the way, this is not, of course there is more, okay? If you look at blue, it talks about configuration management. You guys using configuration management? You probably use only one of them if you do, right? What you have here, some fancy Chief, Ansible, Puppet. Maybe we don't use all of them. Maybe we use something else. The point is that a modern DevOps team is bombarded with options, with offers from vendors how to make their life easier. And oftentimes, indeed, these tools can make your life easier. But how do you manage all of these tools across? And now, just when you start adopting one tool, what happens if you want to change? Okay? So why DevOps is hard? To make it simple, I kind of organize it in 4 main kind of groups of challenges we are dealing with. The first one, change is hard, and we never start from scratch, right? It would be easy if we would all start a startup from day one and pick out tools and make everything automated. Reality is, if we want to improve, we are limited by what we already have in place because nobody will allow us to stop and not do anything for 6 months. Okay, good. Talent scarcity. DevOps, as we saw, involves a lot of complexity, and it's hard to train people, and you probably have around you, or maybe you are that person who knows it all. There are not enough of those people. It's hard to train them, retain them, and find them on the street. So how do you deal with these challenges where you are dependent on one person, what the boss, proverbial boss runs him over or her? Organizational challenges are not to ignore. DevOps are trying to bring together different teams. Just like 10, 15 years ago, many of us adopted Agile and saw how this goes. What we try to do, put in the same team developers and QA. There was some friction. I saw frictions in different companies I worked on. Today, mostly it's an accepted norm where, although they're different specialities, they work together, common working product. DevOps, the same world. There is little trust traditionally in the traditional operations side of the house, IT, and developers. They don't get access, they point fingers, they don't respect dependencies. So how do you learn to work together? That's a challenge. Tools, we talked about tools, plenty of tools. In fact, so there are a lot of different UIs, command line interfaces. I have another slide on tools to be more specific about that, but at the end of the day, you need to make a choice. Which tool you pick? Do you invest? Do you take open source? How do you integrate them? So, in thinking more about this, we realize that there are different personas that we want to understand their needs that may be impacted by performance of DevOps team, and specifically by how, if there is a pipeline, how it is organized, and why do you need a pipeline, in fact. So the first persona we are thinking about is a DevOps manager, somebody who is looking holistically at the organization that produces working product. These are strategic, high-level needs, but you want to see end-to-end and you want to look at the ways to improve productivity of your organization and how to be more predictable and reliable in projecting forward your commitments to stakeholders. You have DevOps engineers. My view is that it can be a developer, it can be QA. It's anyone who is on a team who has a specialized, potentially skill set that contributes to producing working product. How do they work together? Today they have, coders working compiler and editing code, but then somebody else is helping to build and do release and deploy. So it's a cross-functional team that will benefit from improved visibility, collaboration, and automation. Product managers, not often spoken about, so I'm upset because I'm a product manager. Do I look like? No, I look different. So importantly, those products, when they're built, if you are hosting or if you ever planning to host, then this is essentially your product. So you want to see how they're used. I would want to see who is using my products, which features are being used. Is it loaded? Is it functioning? Is it popular? Do I need to do more or less? This type of knowledge will be highly valuable in order to decide where to invest more. Okay? Is my feature ready? Is it still in development? When will this release be or that? So managing and communicating, understanding all of that is valuable to owners of this, or business owners, or line managers sometimes. And the pipeline manager is a role that I call it pipeline manager, I don't know if it's a good term, but somebody who actually spends this difficult work of integrating everything and maybe taking away all the complexity so that others can benefit on a configured pipeline. Okay, so creating uninterrupted flow of value creation. Now, in summary, what we have discussed so far, DevOps more or less is understood, maybe differently. There are books, there are success stories, many of us are practicing or at least interested. We want to get value out of that. Good. We know there are some challenges in DevOps. So now specifically, if you look at OpenEdge world, we have certain specific pieces that OpenEdge contributes its own complexity, whether you are developing ABL code, configuring and deploying database, dealing with integrations, application servers. So how to enable you to build OpenEdge in a modern way using this setup? So I have here a little summary that also contributed to our thinking. We as a software organization also having the same challenges. So progress is building software, so we also want to do it effectively and fast. Granted, we are not hosting software, but we have cycles. We have continuous development, we have testing, code coverage, security scanning, deployment. So believe it or not, we actually hired people and brought into organization with extensive DevOps experience to help us upgrade our processes and tooling so we can produce more and faster for you. So some lessons that we learned, maybe nothing special, but nevertheless I want to share. Before we started, we made sure that our goals are clear and we are aligned. And that's important, especially in a larger organization when not everyone may be on board. Why are you doing that? If it worked 20 years, why do we need to change something now? So we used some techniques to measure and establish a baseline of, we were looking to identify a constraint. Because if you don't identify a constraint and just jump into changing something, you may not necessarily derive the benefit or enough benefit. Addressing constraint first will really unlock your bottlenecks and enable your flow to flow faster. We found, for example, that our developers, due to the use of we use ClearCase, and the way it was configured, oftentimes even a small change required them to wait several days to see if what they built didn't break anything. Plus, we had multiple sites in India and in USA. So analyzing, understanding where we truly waste time helped us to focus our priorities, and we moved to Git. A lot of us, most of our teams already moved to GitHub. I think there are some, maybe there are a few more left. But that helped us to focus and measure and then compare to baseline and a lot faster. So as a result, we're able, with the same amount of people, produce more value faster. And celebrate victories. So I say in the end, don't forget to help. This helps organization to go through change better. Automation is a natural thing, but we also learned that not everything makes sense to automate, and not to be naive, leave some room for manual where it makes sense. Production not equal deployment. So what I mean here is that deploying the same binary in development and production is a good practice, of course. Configuring your development environment the same as production may be impractical or actually not beneficial in terms of facilitating faster flow. We found that there are a couple of examples here. In OpenEdge 12, we introduced digital code signing capability, and in our initial development version, we had it by default on. So as we went through testing, we were wondering why the compilation and build time reduced, significantly became slower. And the lesson learned there was that maybe this is something that you would want to leave to the very end and not necessarily slow down your developers with minor changes to validate if there is no regression. So this example where you can be smart about where you apply digital code signing. You can do it later. Another example is database deployed using Docker containers. Early on, when we looked at this opportunity, we ruled it out as unacceptable from production point of view, since containers are transient in nature and they can go away if you deploy them. If you're not careful how you configure Kubernetes orchestration, they can be blown away as unnecessary with loss of data. However, with the help of collaboration, hearing from customers, we reconsidered our approach from the point of view of helping in development stage. In development stage, it would be very helpful to bring up a clean database using container technology and accelerate development cycles that way. Minimizing tool dependencies. There is a lot of churn in this world. That periodic table that I showed you is changing almost every day. They get updates from new vendors. You want to be free to benefit from new opportunities to improve performance and productivity. So try to minimize. Now, we are not married to one tool, and you're probably not married to one tool. Either way, it's your choice. We are not intending to lock you into any particular tool selection. I think generally we want to be open. And whatever we do, don't overcomplicate, because all this automation and intelligence that we are building will need to be maintained. It's kind of easy to build, but over long term, if you don't plan for maintaining this, you're going to suffer, incur cost. So if you are OpenEdge shop, where do you start? And this is a bit forward-looking. We are not ready, obviously, with this project. We are working towards that. This is what we are hoping you will be able to answer soon. So before I go too much further, I was surprised to discover that Gartner, well, to my detriment, I should have known this. Actually, Gartner recognizes the whole market segment they call DevOps toolchain orchestration. And this is exactly what we set out to do with the hub. The only thing, this is fairly new domain. You can read the description. I won't read it for you. They recognize this as a transformational technology with 5 to 10 year span. So they predict in that amount of time it will become mature, mainstream, adopted. The challenge they see is exactly what we are trying to address, that in order to improve collaboration across a DevOps team, with all the proliferation of different tools, there is no easy way to bring a single pane of glass and kind of lower the bar to help you all get on the same page and understand how your work impacts your colleagues, how to plan these dependencies, resolve risk, and be on the same page. Just use common language. So if you look at the hype, this is from July last year. They actually put DevOps toolchain orchestration right at the top, just before the hump. So let's watch where this is leading us. Project Hub. Okay, so Project Hub goal is to enable cost-efficient, team-based DevOps of modern cloud-centric OpenEdge business applications. Now, I say cloud-centric, it can be hosted. Strictly speaking, even if you don't host, you will derive some benefits from optimizing how you develop, build, test, okay? But of course, if you are planning to go hosting, if you're already hosting, that will unlock even more benefit by extending to deploying stage and operating and monitoring. We started off first a year ago in Boston at Progress Next. We actually had a booth, and we showed, if you were there, you may, how many of you were last year at Progress Next? A lot of you. Oh, okay, great. So maybe you remember there was a booth with Eclipse Chi-based PDSE. So we tried to see if we can modernize IDE first. And we found a lot of good things. For example, it works nicely for larger distributed teams. People from, it's easier to administer configuration because you deploy it centrally and people can access development environment workspace from their web browsers. They could share workspaces. You could have multiple OpenEdge configurations set up at the same time, and you can test against, let's say, OpenEdge 12, 11.7, right? So that's all good. But as we learned, as we got feedback, and we discussed at Virtual Open House on customer validation program, we identified this bigger need for DevOps enablement and pipeline in particular. So our current focus is switched to what we call cognitive CI/CD pipeline. Why do we call it cognitive? Well, there are three stages in this approach. The first is to actually visualize a pipeline, and I will show you some screen wireframes. Visualizing gives everyone the same language. We can see how what we do fits, and it's a springboard into whether you want to go edit code, check out code from the branch, deploy, configure environment, monitor, see resource utilization. But if we go next step and instrument the pipeline and collect metrics and measures about where time is lost and how efficiently the changes propagate through the pipeline, it will empower us to make more intelligent, automated decisions about when to kick off next steps. For example, you may make changes in the part of the code that has something to do with the visual cosmetics or layout of controls. Or you may make changes that are deep in the brain of a business logic. If you do a formal one, why run the full regression suite that takes 2 hours when you can run a quick one just to make sure that the application can be brought up, which takes 5 minutes? This is the time you can save. So if we can, down the road, automate the pipeline to make those decisions intelligently, we could save time if you multiply by number of times your developers do that. Another example, if you know that when your performance testing or let's say security scanning reaches 80% complete, you can start preparing infrastructure for preview or staging next stage. And that may take time using infrastructure as code, like Terraform, for example. But if you start in advance, by the time you're done with the previous step, that environment will be ready. Again, time saved. Those are some examples of intelligence that we are looking to unlock. In addition, realizing that OpenEdge is not kind of going to cover all the needs to enable you more, we want to make it easier to integrate or enrich your business applications with cloud-native services such as native storage, cloud storage. Another example could be Google Translate services. So selectively, based on what we will look to make it easier to bring to your fingertips and other cloud technologies that enrich your applications. This is a conceptual kind of sharing with you, so I'm very much looking forward to hear back, share your thoughts and feedback, whether this is something you'd like us to develop more aggressively. Now, what I want to highlight here, coming back to this continuous loop, is that all of these different activities are supported by dedicated environments. Environments are basically configured infrastructures that your IT or somebody in your organization needs to make available for teams to work. So if you're coding and building in a traditional world, we have developers who have desktops under their tables, under their desks, and they like to be independent because it takes a long time to wait for somebody to provision another drive or database or server for you. You want to be faster, independent. But guess what? It's not faster because you have to do it yourself. Every time start from scratch. And the same for performance testing. It's quite an involved step to manage and set up this infrastructure to run extensive longevity, performance, security testing. And of course, production is a whole different world. You want to monitor it for continuous availability and performance degradation and security breaches. So one way that organizations call them preview stage in production. These are just some names. They can be called A, B, C, D. The point being that you can have as many of those environments as you want, from 1 to 5. You can call them 1, 2, 3, 4. From left to right, you are moving basically from very early prototyping, conceptual kind of implementation to increasingly mature and ultimately hardened deployed production that your customers can count on for mission-critical applications. If you are an organization that wants to manage this complexity, realize that not only you need to stay on top to recreate these environments as needed for your business so that nobody ideally waits. You want to eliminate, because waiting is a waste. It means people who could produce value are waiting. So you want to make sure that these are adequately configured on time and have sufficient resources without burning the money of your business on unnecessary allocated capacity. You want to provide. If, for example, in preview, you have developers in your office, let's say 5 developers working, and they have sufficient number of virtual machines with memory, CPU, disk, adequately sized. And then in a different time zone, let's say you have outsourcing or something, 20 developers come online and use the same environment, and their build time suddenly drops down because they're all contending for the same resources. You want to stay on top of that, so you add proactively additional capacity so they can work fast. So that's a kind of challenge we want to help you to manage better with OpenEdge. I tried to mock up earlier, this is about 5 months ago, try to kind of use a Balsamic to prototype all the different tools. I was thinking about 14 or more categories. You probably don't need all 14 categories, but somewhere maybe 5, 6 you need as a minimum to start. You need to have a source control management. Hopefully everyone is on board with that. You need to have some coding, testing, integration tools, configuration management. So that's good. But the point is that for each of these categories, you will be faced with a choice. Our approach is to leave it open. So we want to build a solution that allows you to bring your own. Where possible, we will include the solution and maybe have a recommended integration to get you started. But absolutely, we want to leave it open. There were questions, is Roundtable supported? Of course, Roundtable we want to support. It doesn't have to be GitHub Enterprise. It's just for visual illustration purposes here. So the strategy has been, as I said, we started with the basic development capabilities, and we have built, so the first version we have now posted on customer validation program has Eclipse Chi-based ABL coding environment. It is supported currently for OpenEdge 12, and we are working to extend it to support OpenEdge 11.7, so you can see the benefit of 2 environments and maybe use your existing projects, try to compile. Eclipse Chi is deployed on Kubernetes itself. And Kubernetes is, for those who haven't used it, it's an orchestration technology that can intelligently organize containers at runtime and make sure that you have a high availability and enough of those nodes available and watch them so they don't come down. It supports team development and secure, cost-efficient, scalable, so you access it through browser. And now we are working on a pipeline. I already spoke about this. We are in this stage, focusing on visualizing. So a lot of plumbing and scaffolding work going behind the scenes to build the hooks so that we can ultimately enable OpenEdge development in these automated settings. And future, this is still a bit of a forward-looking. We are not yet going there as far as cloud, but I gave some examples here: cloud storage support, Google Translation, machine learning, IoT. There is plenty of things. We are not going to do all of them, but we want to expose, bring it a little closer to OpenEdge application. So in the workings, I give an example here of what we are doing. So this is pushing much further. I know many of you probably, who is using PASE? Oh, quite a lot. Okay, excellent. So today you can already benefit from PASE support on container. As of 11.7.4, we introduced that and we are moving forward, not stopping. We have initially introduced, when we introduced our first baseline container, which is supported by Progress, as a sample application, we showed you a monolith, one huge monster container, including application, PASE, everything. We have since learned quite a bit, and we're now updating our sample up to show you best practice to use a sidecar container so that you can maintain your application server in a cluster, potentially managed by Kubernetes or other orchestration technology. And then you can plug in license configuration and runtime configuration as sidecar containers. And ultimately, your application container could include your business logic that you developed in ABL. And you can have multiple applications sharing the same application server. Or you can just continue to develop and substitute your application container as a sidecar container. Moving to cloud world, we realized you will need to use something more sophisticated than log files, because log files stored on container can go away. So and plus you can have lots of containers. How do you know where it came from, where to find what? So we are leveraging technology called Elasticsearch, which is a large repository where you will be able to run forensics or analytics, and then use graphing tools like Kibana or Grafana to easily get insights into what's going on when you're troubleshooting or trying to improve performance. So project architecture at a glance will include modular pieces. You will find, for example, IDE on Eclipse Chi is just one of the elements that will be ultimately exposed through the Hub dashboard. A Hub dashboard is a visualization of a pipeline, and I have a couple of screenshots to show you, time permitting. So now if I look at the April release, this is what we released, what's already available for you to download and play. Who would be interested to try this? Okay, appreciate if you post your comments for our team. We would really look forward to hear your experience. Also, to make it easier for you, we are exploring ways to host it on Amazon, so you don't have to download and install, but I want to see some interest before we invest time and resources to do that. Okay, our intent is to continue on a monthly basis to iterate and post every month next increment. So for example, in May, we are looking to add logging capabilities in that release. So this comes shipped with its own Docker registry where you will find PASE container, baseline container, and where you can build your code and package as a Docker container and put in the registry from where it will be taken by a pipeline and deployed. So that process, we are trying to build automation so you can confidently build OpenEdge applications that are then run in this modern technology. Under consideration, some of the other areas are listed here. We will be very interested to hear from you which tools are most critical for you. Where should we pay priority as far as supporting of build system, SCM, CI integration. We are looking to use for live monitoring Prometheus. Again, something that is highly scalable for real-time metrics, retrieval and monitoring. Think about OEM capabilities brought into this world in the context of your pipeline. And with that, I have a few conceptual wireframes. I have 5 minutes left, so I will be happy to share. Would you be interested? Okay, so we are looking here at a view that represents console for product manager. So typically, product manager, the company, organization will host multiple applications. In this case, we have Ledger, Ledger Express, ERP, Parts Catalog. Those are just sample applications. Each one can have a different metrics representing what's critical for managing this product offering. Event log, page views, sessions. So the idea is to make it configurable. You can switch to DevOps manager and see metrics for each application that are more relevant to this persona. On the far right, we see, for example, number of contributors working on that app. Regression testing cases, total features, things like that, code coverage. If we drill in further, if I click on Ledger, for example, I get into the application lifecycle view with the corresponding tabs at the top to do with application monitoring and infrastructure monitoring behind, so you can monitor utilization and basically see how your environment is utilized and whether it's up and running, so work can be done. Going back to the application lifecycle, this is probably the most important view, exploring visualization of a pipeline, and giving ability of different users to see how their work fits. Each of the circles can be clicked, so currently code is selected, so we can do work on code branches. So suppose from here you can go right click and go to edit your code, where you can go to editor, depending what you configure. All of these stages can be configured, so you can have this are flexible. You may not need have performance test, or maybe you don't have release if you're building prototype. Maybe you just want to stand it up and show. Also, each of the environments here, we see preview, staging, production. You can monitor, let's say you go to production and you see its health. Right, so now I need to go back. And I came back here. What else? So different pipelines can have different configurations. As you can see, stages can differ. Hotfix doesn't have performance testing in this case. So this is just to give you some taste of what we are thinking about and evolving this further. And I think that's pretty much what I had to show you. Any questions? What was the question? What was the question?
What would it cost?
Ah.
What are you going to productize it, or going to offer it to?
Yeah. So we want to go forward for about 6 months more on a monthly basis, iterating. If we see something that promises to offer value and will help you be successful, then we want to turn it into a shippable, supported product. And so all of this discussion hasn't occurred yet. We are open to discuss this on the customer validation program, which is environment under NDA. Yeah. So I'll be honest, there is no even product name here. But the more we discuss, the more we see opportunity to enable. The intent is, quite frankly, to make it exciting to work with OpenEdge, make you successful in building solutions fast, make you competitive, and cut your cost. So if we can achieve it, it's a win-win for both of us because we end this together. Sounds good? Thank you very much.